This is part 4 of modeling and simulation of a simple parallel bus system. In this video, we will assign electrical models to different blocks we have placed in workspace area, like memory model, controller model, and tuning blocks. So let's get started. In the very first step, we'll open topology created in previous 3 videos. If you don't have it, you can download it from the link given in the description. Once you have downloaded that, you can open Topology Explorer 22.1, select the Advanced SI2 license and click on OK. Once the Topology Explorer is open, you can go to the Open button, select the topology that you have downloaded and click on Open. In the next step, we are going to replace the default IBIS model in controller block. To do that, you have to double click over controller block and property editor will open. From here, as you can see, as of now, PBA_EX IBIS model are assigned. You have to click over this edit button. It will direct you to this window. Now here you have to browse for the model. You'll find it inside the same folder that you have downloaded. Select the IBIS model, which is DDR_PBA_EX and click on open. Once the IBIS model is open, you have to make sure all the data lines and address lines are assigned properly. To do that, first you have to make sure the bus type is correct. So as you can see, this is data and address and command signal bus type. Then you have to select bus group, which is address and data L. Then you have to change the timing reference. So as you can see, the timing reference, which is data strobe signals, is LDQS and LDQS has are properly assigned. If you wanted to change it, how you can do that? You have to just click over this edit button and from here you have to select the correct signals and move it in the positive and negative tab. Alright. Next you have to select the edge type. So as you can see, the edge type is both edge. And if I'll make it a bit wider, you can see all the signals that we have placed in this signal group. Alright. So as you can see, this is the lower byte of data group. Now we are going to add another byte that will be upper byte of data group. So click over add button. Let's rename it data U. Select the timing reference. So this time we have to select UDQS as a positive signal. As you can see this positive sign here, and UDQS has as a negative signal. Then click over this arrow to move it in this column. Then click over OK. So as you can see, the timing reference are assigned. Now since it is a upper byte of data group, then the signals will start from DQ8 to DQ15. We'll click over this E button. Select all the signals from DQ8 to DQ15 using Shift key and just select those. Alright, so as you can see, all the signals are selected. Then click over OK and you can verify it by extending this column. We have selected from DQ8 to DQ15. Alright, once it is done, we'll click over OK button. After assigning the IBIS models to controller block, we are going to assign IBIS model to memory block. The process is very similar. You have to just double click over memory block, edit the IBIS file, browse for the correct file, click on open. Now here make sure memory is selected. To make things easy for you, because all the process is same, I've already filled all the details here. Alright, so your job is to just verify all the details are correct. So we have lower byte of data groups. Its timing reference are correct, both edge, and make sure you have selected DQ0 to DQ7 and same for the upper byte. Alright, then click over OK. Now after assigning the IBIS models to controller and memory block, we are going to sub-circuit model or a S parameter model to tuning block. To do that, you have to double click over tuning block, and as you can see, it has some default model assigned. We'll just edit it. Locate where you have placed the model, which will be strobe_tuning_trace for all. Just select it and click over open. Alright. So what is this tuning trace model? So this model is all about assigning transmission line delay and its impedance. If you wanted to verify that, you can just click over view sub-circuit button. And as you can see, here we have assigned the propagation delay to data and data strobe and assigned impedances to data and data strobe signals. All right. And as you can see, these are all the signals defined that we have defined in previous part of this series, right? Then click over OK. So here we go. Till here we have assigned all the electrical models to controller, memory block and tuning block. In the next part of this series, we will define connectivity between blocks and see frequency response of connections between them. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.